And are you trying to get at, do we count the inside surface area? Is that what you're trying to get at?
No, I was just wondering if like it was hollow or not.
Okay, yeah, it's hollow. Unless it specifies otherwise.
Well, now that you mentioned it, do we count the inside surface area?
Yeah, no, that's a good question. So this is literally half of this. So it is just counting the outside. What do you think it would be if you counted the inside too?
Same, I guess.
Yeah, you would end up with a total of the same surface area. So I think that when you're doing problems, assume that it's going to be just counting the outside surface area, but know that it's totally possible that they could count the inside surface area as well.
Okay.
And that's how you would figure it out.
Oh, okay. All right. That makes sense.
Okay. So we're going to do some examples. Before we move on, I have an example for, I think, each type of shape that we've talked about. And we're cutting it close. I really want to give you guys these examples. If we go over a little bit during our virtual meeting today, is that okay with you guys? What I'll do is, since I'm recording, if you really need to go, hang up. I will post the recording after class. But if not, stick around and we're going to go through these examples. So we're going to start with an example with a right pyramid. Okay. So I'm going to draw it out. I should have drawn the base first. I'm dumb. Maybe it'll still work out. It obviously doesn't have a square base, but it's okay. All right, so this is a right pyramid. I'm going to label it A, B, C, D, E. We have our little middle piece right there. Oh, it's so ugly. Okay, so this is a square base pyramid. And its name is A, B, C, D, E. Okay, I'm going to tell you that it has a height of 6 centimeters and the length of one side of the base is 10 centimeters. Now, because it's a square, we know then the length of every single side of the base, right? So this length, 10 centimeters, and all the other ones would be 10 centimeters as well. So it says also that M is the midpoint of CD. Okay. Part 1 is to find the length of EM. Part 2 is to find angle EMG. So M, it says, is the midpoint of CD, so our M is right here. Let me grab a different color so that we can highlight the things that we are looking for. Okay, so the length of EM goes along the edge of my triangle and is the slant height right here. Okay. EMG, so this angle EMG is going to go, oh, did I not label G? G is this guy. That point at the bottom. So angle EMG is going to go along here and then go to the middle right there. So if I pull out that triangle, it would look like this. And E is here. M is the midpoint. G is that center point in there, and you know that that's a right angle. I did a really bad job drawing that so that it's easy to see. I apologize. Okay, so to find the length of EM, EM is this guy right here, right? So it's the hypotenuse of that triangle. Do I know anything about this height or MG at all?
Height is 6.
Very good. We know that this is 6. What about MG? Do we know any information about that?
Yeah, it's
What is it?
5.
Yeah, 5. Why?
Because the line is half of the outer side lengths, which are 10.
Very good. Yeah. So it's half of the outer side lengths, which are 10. So we know that this guy is 5. This is the thing that goes along the floor of the pyramid right here. Okay. So to find EM, I'm going to set up the Pythagorean theorem with my legs, the sum of my legs squared equal to EM squared. So 6 squared, 36, 25. What's 36 plus 25?
61.
Beautiful. So this tells me that EM is the square root of 61. What questions do you guys have? Okay, the next one is find angle EMG. So EMG is this angle right here. What relationship, what two side lengths that are, we want to use the integer ones if we can. What two side lengths do we have, and what trig function will we use to incorporate those two side lengths in that angle? So here's our angle. 6 is it the opposite, the adjacent, or the hypotenuse?
Opposite.
Yeah. Opposite, and then 5 is
Adjacent.
adjacent. So which trig function uses opposite and adjacent?
Tangent.
Yeah. So we know that the tangent of angle EMG is going to be 6/5. Okay. To solve for angle EMG, we have to do the arctan of each side. So angle EMG is going to be tangent inverse of 6/5. And we can do that on our calculator. So we would look for a function. We would do tan inverse 6/5. Oh, that's 65. And you should get about 50.2 degrees. And we want to consistently try to use 3 significant figures when we do our work, or leave things as a not rational, as a radical number. What questions do you guys have about that one? Okay. We have we have 3 more. It's currently 1 minute past our time. If you need to go, you need to go. I will post this. I will post both the finished examples and the video of it. If you get confused, you can always reference that. But I'm going to go ahead and move on and try to go pretty quickly. So the next one is the right cone. I'm going to draw a picture. Okay, so this right cone has a radius 20 centimeters, and the angle of the slant height with the base, and the angle of the slant height with the base is 60 degrees. Our goal is to find AC. It would be helpful if I labeled my cone. So A is here, C is there. I'm going to pull out, so basically this makes a triangle right there.
Bless you.
Thank you. Okay, A is here, C is here, right angle, and this is 60 degrees. Our goal is to find AC. Oh, and we also know that this is 20. We need at least the side length. Okay. So we can set up a relationship. We know that the cosine of 60 degrees, so cosine is adjacent, which is this 20, over hypotenuse, which is what we're looking for. So it's 20 over AC. And so now we only have one variable, AC, to solve for. So I'm going to multiply by AC on both sides. Okay. Cancels out over here. And then we end up with AC times the cosine of 60 degrees equals 20. Divide by cosine of 60. And we should get the AC. So the cosine of 60 should give us a half. So then when we, when we have half in the denominator, we would do the keep, change, flip thing, and you end up with 40 centimeters as your length. Okay. Since we're past our time, I'm just going to keep moving on. I, again, will post all of this stuff afterwards so you can come back. The next example that we're going to do is a sphere. Okay, so I want you to find the volume and surface area. I'm going to abbreviate of the sphere with radius 4 centimeters. Okay, so I'm going to draw my sphere out. It has a radius of 4 centimeters. Volume is just 4/3 pi times 4 cubed. So you should end up with 256 over 3 pi centimeters cubed. Surface area is 4 pi times 4 squared. So 64 pi centimeters squared. Units are super important. Also, if you have a pi in here, it's just nice to leave it in terms of pi. It makes everybody's life easier to have a rational number and then your irrational number in the form of a variable. So if you end up with pi, just leave it there unless it specifically asks you to give a decimal out to 3 sig figs. The next one is the hemisphere.